Hello, my name is Caitlin or Kate Taylor. I'm recording this on June 27th. I kind of messed up my 7th, so I scribbled it out and rewrote it. So June 27th, 2025. This is my Unit 2 presentation, my mapping demonstration. So here we go. As you can see, Unit 2 presentation for mapping demonstration for genetics. There we go. Organizing the data set into a table. So here is all of the data set that we were given. So on the left-hand side, we have the genotypes and then the number of offspring on the right, each one corresponding. All together, this is all added up in a later slide, which does help with some of our calculations that we go through. But as you can see, plus, plus, or positive, 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 1340, ABC 1362, positive B positive 400, A positive positive 100, A plus C 420, positive positive C 970, positive BC 140, AB positive 1010. And then from there, we can kind of organize it into the recombinant classes and the double recombinant classes. So the first one, positive, 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 1340, has no crossover, so it's parental. ABC 1362 also has no crossover, so it's also parental. From there, we get into the more recombinant and double recombinant classes. So positive, B positive 400 is a single crossover, so it's recombinant. A positive, positive 100 is a double crossover, which means it's double recombinant. A positive C 420, single crossover, recombinant. Positive, positive C 970, single crossover, recombinant. Positive BC 140 is another double crossover, so double recombinant, and then AB positive 1010 is a single crossover recombinant. So those are the classes there. For now, we do the map distance calculations. We do that for A to B and A to C, so that way you can figure out the exact map distance. As you can see on the right-hand side here, I did add up all of those number of offspring because that is something that you need in the calculation. So all of these altogether equals 5,742, which we use here in our map distance calculations. So the B to A distance is the recombinants divided by the total offspring times 100. So 1060 divided by 5,742 times 100, that equals 18.46 centimeters. And then A to C distance is the recombinants, same thing, same equation, the recombinants divided by total offspring times 100. So you get 2,220 divided by that same number of 5,742 times 100, which then equals 38.67 centimeters. So now we have our map distance calculations. Then we can kind of go ahead and do our calculations of the coefficient of coincidence in the interface calculations. So the observed DCO, A positive, positive is 100, and then positive BC is 140. So adding those two together is 240. And then you do the expected DCO, so 1060 divided by that same number of genetic offspring. So 5,742 times 2,220 divided by 5,745. And those were the same numbers that we used on the last slide for map distances. From there, you get 0.1846 times 0.3876. And then from there, going forward, you get each one is, as you know, that's the map distances just without the decimal point moved over. So then from there, you actually take those two. So the 1846 goes to this part of the equation, and the 1367 goes to this part of the equation, and then you actually go ahead and divide these two together. I'm sorry, multiply them together. Overall, you get 410. From there, for the coefficient of coincidence, you take this number and this number and divide them, and then that's where you get our coefficient of coincidence, which is 0.585. For the interface, you do interface equals 1 minus the coefficient of coincidence. So you're going to do 1 minus 0.585, which equals 0.415 for our interface. A very basic map just to kind of show the exact distances between B to A to C. Thank you so much, and have a great rest of your day.